Here is a statistics question, paired t-test, coffee consumption and productivity. A company conducts a survey to determine if drinking coffee increases productivity. A random sample of 50 employees measures their productivity, tasks completed per day, both before and after consuming coffee for 2 weeks. The mean of the differences, before minus after, is 1.4 tasks with standard deviation 2.5. So if the mean here is positive, that means before is bigger. This is the larger value. The question asks, or the prompt is, test whether drinking coffee increases productivity at significance 0.01 using the four-step inference process. Well, if it increased productivity, the after would be larger, and the mean would be a negative number. So in this case, the null hypothesis is that before minus after equals 0. The alternative hypothesis would be that before minus after, it says drinking coffee increases productivity, would be less than 0. And I think maybe there's some mistake in this question, that maybe the mean of the differences should be negative 1.4, or else it should be after minus before, because this positive mean of differences doesn't jive with a left tail test. But I'm just going to work it according to the numbers that are here. Test whether drinking coffee increases productivity. So the sample mean is 1.4. The null is 0. Should be no difference. The sample standard deviation, that shouldn't have a hat over it. That should just have a 0. This should have a hat. Standard deviation is 2.5 tasks. And let's see, sample size is 50, and significance level is 0.01. Not sure why it's that. To me, it should be 0.05, but okay. And so let me see. Is this random? Yes, it is. Is there more than 50 employees? Yes, there is. Do I know the population standard deviation? Nope. So I'm going to use a t-test. Is it paired? Yes, because there's two separate activities being undertaken by the same group. They are performing tasks before drinking coffee, performing tasks after drinking coffee. So I've got two different things. That's why I compare them like that. Again, I think this one should be after minus before, and then it should be greater than 0. That would be increased productivity. But I'm just going to do it according to what it is. So let me find the t value. It's going to be the calculated mean minus the null hypothesis mean divided by the standard deviation divided by the square root of the sample size. And I will do this on a TI calculator. Where's my T? I had it just a second ago. Okay, so I will do I'll put parentheses, 1.4 minus 0, I'll close the parentheses, divided by, of course that's just going to be 1.4, so I could just write that, divided by, what was the standard deviation again? 2.5, yes, divided by 2.5 divided by the square root of, I don't think I got the division in there. Hold on. Divided by the square root of 50. Now I think I have everything in there. And I hit equal, I get 3.96. T-value is 3.96. See, now this is the weird thing. Here is the curve. The t-value is up here. So that t-value suggests it's a right tail test, but this is a left tail test. So I'm going to have to, whatever p I get, I'm going to have to do 1 minus the p to get this one. So let me do this on the TI-84, find my p-value. I'll go to second, vars, down to TCDF. Boom, I might already have these in there. Yes, I already do. The lower bound is 3.96. The upper bound is huge number. Degrees of freedom is 1 minus the sample size, 49. So I go down here, I'll paste it, and then enter, and I get 1.2. I will switch that. I will do times -1. I will switch the sign so that I can subtract it from 1. I'll just put +1, and then I'm subtracting it from 1. I get 0.9997. So that's about equals 0.9999. You know, it's very close to 1. So remember, this is the p-value I found, but I want this left tail. So I have to do 1 minus that so I can get this part. So 0.999. 0.9999 is greater than the alpha value, which is 0.01. So therefore, I better go ahead and fail to reject the null hypothesis. There is not compelling evidence that productivity increased. That is the answer to that question.